Hi, good day. Welcome to Logic Design Lab experiment number 3. I hope my voice is audible. So let us start with experiment 3 today. This is your lab report for experiment 3. Before I begin, I would like to just share you information about that it is found that most of the students are not filling these details. So please give your name here, your section ID, and the lab course, and today's date, and the date of your submission, and your university ID and your serial number. This is experiment number 3, and deadline is it's a 1 week, and this is filled by me. I'll give you the marks after evaluation. So write the title of the experiments and objective. Again, it is observed that in most of the labs, students are doing mistakes here and losing marks. For example, in this experiment, suppose if you are using switch, so write the equipment name as switch. Okay, and you are using LED, so you can use LED. If you are using AND gate, write AND gate. If you are using OR gate, use OR gate. If you are using text, use text. And also, instead of model number, I have mentioned that you have to write its type. Okay, like switch is a input device. Okay, LED is an output device. Then AND is a control device. So similarly, you just do for write the type of the device is it, and where you will get this information. This information you will get it from the textbook, which is uploaded in the Blackboard. Okay, uh, so make sure that you see this. So OR gate is also a control device, and text is a fixed output device. So let's go for the important thing here. Yeah, this is the first experiment about encoders and decoders. So before I begin, I'd like to just give you some information about these two circuits, encoders and decoders. I'll just begin with first decoder, then we'll come back to encoders. Okay, encoder and decoder circuits. Let me first begin with decoder, then we'll go for encoder. So what is decoder? It is a logic circuit that will detect the presence of a specific binary number. A logic circuit that will detect the presence of a specific binary number or a word. Now you need to remember that a decoder is a combinational circuit that converts binary information from n input lines, okay, to a maximum of 2 per n unique output lines. So it is a combinational circuit. Okay, that converts binary information from input lines. So inputs are how many? N input lines. Okay, to a maximum of output lines of how many? 2 power n. And generally we'll use an AND gate Okay, for AND gate is used for basic decoders circuit. So let us start with first 2 to 4 bit decoder. What do you mean by 2 to 4 bit decoder? So I'll just use here 2 to 4 bit decoder means 2 is input lines and output is this 2, this 2 power 2 is equal to 4 is output lines. Okay, so let's go to our lab report, step number 5. Okay, now construct 2 to 4 line decoder. So means 2 are the inputs and 4 are the output lines. Okay, so let us give a connection, and you have also seen that we have used AND gate for constructing this decoder circuit. So for this, we'll use multimedia logic simulator. So let's go for Logic software. So let us give connection according to the circuit here. You have A and B as in two input devices, and so we take two switches as an input devices, and you have two NOT gates also, and four AND gates, and four LEDs, and you have text. So I'm just drawing as how it is there in the lab manual. So let us give name. This is given as switch A, right? And this is given as input B. Okay. So and F1, F2, F3, F4. So it gives the name as F1. This is F2, and this is F3. This is F4. I see it's recording. Yeah. So now let us give connections as shown in the diagram. Okay. So this is connected from A to NOT gate and NOT to and B is also connected to NOT, and this NOT is connected to B. So this is F1, and this is F2, so F3, and F4. Now let us connect them as shown in the figure. So now my circuit is ready. So when there is 0 0 as an input, so as I have told you that the the decoder is a logic circuit that will detect the presence of a specific binary number. Okay, so the binary number 0 0 is nothing but it has detected it is 1. Why? So if it is 0 1, so I mean I'll just make it sure that this is F0, so that to avoid confusion, this is F0. Okay, and this is F1. I'll just make it here convenience. Okay, F0, F1, F2, F3. So now I run that this binary F0, 0, 1, so it will detect 1, 1, 0 means 2, 1, 1 is 3. So it is detecting. So a logical circuit is detecting the presence of a specific binary number or a word. So now let us go to the lab manual. So yeah, so here we have seen that if A is 0 and B is 0, okay, so just change these labels for convenience. Just make it as F0, make it as F1, make it as F2, make it as F3. Okay, so A0, B0, it is detecting this LED 0 and remaining all it's 1 and remaining all are zeros. Then I make A is then I make 0 1. Okay, so 0 1 0 1, so it is detection F1. 0 1, it is detecting F1 and all are zeros. And I make B as 1. And I make, okay, just let me change this also, right? A and B. Now you see here, both are 0. A0, B0, it is detecting F0. Then I make A as 1, 0 1, it is detecting 1. Okay, then I make B as 1. Then I make B as 1, it is detecting that it is F2. So B as 1, it is detecting F2. Remaining bits all are 0. And then I make both of them as 1, then it is F3, it's detected 0 0 0. So now you stop the simulation. I stop the simulation. Okay, then after stopping the simulation, it is given that explain the above truth table. Now you need to explain this the truth table. Okay, that what I have explained, just write that in English. Okay, so it is detecting the presence of a specific binary number. Then inputs are 0 0. Then its corresponding the value, but the binary value is 0. Right? If the binary value is 0 1, then the value is 1. If the binary value is 1 1, then the value is 3. So it is selecting 3. And you also observe that the diagonal elements are 1 here. Okay. So now you can also draw the circuit. Uh, it's already drawn here, right? So for you to get a clear picture about how these connections are done, right? Before that, you have to write let's F0, this is F1, this is F2, and this is F3. Okay, you can draw it like this. I'm just drawing here this circuit to avoid confusion. That suppose we are having A and B. Okay, so because I have written here reverse, so let's give this as A and give this as B, right? So, or you can keep A and B same and change here A and B. Okay, so it gives accordingly. So you will have uh, the circuit, actual circuit will look like this. You have 4 AND gates, 1, 2, 3, 4. Okay, so first is connected to 0 0, 1, and the next is connected to And finally, okay, this is the circuit. This is F0, F1, F2, F3, and this is VMA. So you can draw the circuit for simplicity in this way also. So you can write here A, A bar, there is not, B and B bar, okay, and just draw these lines, and you have outputs F0, F1, F2, right? So for F0, okay, so it is taking from A naught and B naught. So for this, you need to write the Boolean expression for this. Okay, for F naught is A bar, B bar. Okay, and what is the Boolean expression for F1? F1 is 1 here, so A B bar, A B bar, and F2 is A bar B. F2 is A bar B, and F3 is AB. F3 is A B. So you can write like this. You have A bar B bar. So this AND gate is having from A bar B bar. Okay. Then next is F1. So F1 is A B bar. So you can have A and B bar. So A and B bar. And then you are having F2. F2 is A bar B. So A bar B, and then finally you have F3 A B. Okay, so like this also you can draw the circuit for getting the connections clearly. Okay, so now you are supposed to do, after doing this, let's go to the 8th bit. Okay, and try to solve, because first we have seen a decoder circuit. So let us see this decoder circuit, which is 3 to 8 line decoder. Okay, so 3 to, just, so I write here 3 to 8 line decoder, DECODER. Now how do you get this 3 to 8 line decoder? So we will use the above procedure to draw the circuit for 3 to 8 line decoder and run the simulation to fill the output. So how do you get the 3 to 8 line decoder? In 3 to 8 line decoder, we know that you have how many inputs? Inputs are 3. And how many outputs? 2 cube, which is 8. Okay, so I will have 3 inputs and 8 outputs in 3 to 8 line decoder as shown in this table. Okay, so I have 3 inputs and 8 outputs, right? So let us see here, like in 2 to 4 line, 2 inputs, and you have line having 4 outputs, correct? So now let us draw a circuit for it, in which you have how do you draw the circuit first? Okay, let us See that suppose you are having here A, B, and C, and these are the inputs. Like you have A, B inputs, and you have got the outputs as F0, F1, F2, F3 here. So here I will take outputs as F1 to F0 through F7. Okay, so I take F0, F1, F2, F2, F3, F4, F5, F6, and F7. So now I give all the combinations. So 0, 0, 0. If it is 0, 0, 0, it should detect this, and remaining all are 0, 0, 0, 0, 0, 0, 0. So I'll do one thing. I'll just copy this. Let me just make this 0 and copy all. Just paste it. Okay. So it is 0, 0, 0. LED 0 will be enabled, right? Then you will have 0, 0, 1. Then I want LED 1 to be enabled, right? And 0, 1, 0, then LED 2 need to be enabled. Okay. And 0, 1, 1, then LED 3 has to be enabled. Then 1, 0, 0, then LED 4 has to be enabled. Then 1, 0, 1, then LED 5 has to be enabled. Then 1, 1, 0, LED 6 has to be enabled. And if I make all ones, then LED 7 has to be enabled, right? This has to be enabled. So this is the table we have got for 3 to 8 decoder. So let us okay, we got this table. Now seeing this table, we can draw the circuit now. How do you draw the circuit? So here in this case, okay, you will be having A bar, B, B bar, C, and C bar. Okay. So now you need to write down the Boolean expressions for each one of them. Okay. For example, F0. The Boolean expression for F0 is A bar, B bar, C bar. A bar, B bar, C bar. Because only this is one and all are zeros. If you take for F1, F1 is only one here in this. So this is A bar, B bar, C. A bar, B bar, C. Okay. Similarly, if you take F2, so in F2 you have A bar, B, C. F2 is A bar, B, C. Like this, you have to write all up to F7. Okay. And because we are using AND gate, we know that. So we have to put AND gate here with 3 inputs. Okay. AND gate with 3 inputs. And AND gate with 3 inputs. So on up to 7. So you need to complete this in your lab record. Okay. So for F0, what is the Boolean expression? A bar, B bar, C bar. So it should connect from A bar, B bar, C bar. So this is the connection point. Next is A bar, B bar, C. So this is A bar, and this is B bar, and then this is C. Then F2 is A bar BC, F2 is A bar, this F1, this is F2, this is A bar B and C. F2 is A bar B bar, this is C, right? This is C here. Not this. Okay, so like this you continue drawing the circuit. Okay, you'll get it. Now this is about decoders. Now let us come for encoders now. So what is an encoder? So this circuit, hope you understand, you can draw here. Mm, yeah, 3 to 8 line decoder. So here fill the table in your and draw the circuit. So where you will fill the table as shown in the diagram. Yeah. So here you have to draw the table and also draw the circuit for 3 to 8 line decoder. Okay. Then next we will see for encoders now. Let us see for encoder. So what is an encoder? Encoder circuit. So let's go back to our notes. Here I will write. Yeah. The definition of an encoder circuit is that it is a digital circuit that performs inverse operation of a decoder. A digital circuit that performs inverse operation of decoder. So what is decoder? We have already seen, right? So inverse of decoder is an encoder. So it means that an encoder will have 2 power n inputs, okay, and 2 power n or fewer inputs, okay, and n number of outputs, n number of outputs. The output lines as an aggregate generates the binary code corresponding to the input value. This is very important. Okay. Output lines as an aggregate generate the binary code corresponding to the input value. So this is very important. Just note down that the output lines as an aggregate generates the binary code corresponding to the input value. Like we have seen in decoder, okay, when I give binary presentations like 1 0, it is selecting 2. Now here it is different. Now we have 2, it should give you the binary sequence 1 0. Okay, so for that, it is also a combinational circuit that accepts one or multiple inputs and generate a specific output code. It will generate a specific output code, and only one input is triggered at a time. This is very important. Only one input is triggered at a time, right? So now let us see it's working now. So I'll just go back to step number 2. Okay, so this is step 1, 2. Please see the step number 3 and above the circuit. Okay, now you see here you have n 2 per n number of inputs, okay, and n number of outputs. So inputs are 1, 2, 3, 4, 5, 6, 7, 8 inputs. So 8 inputs are written as 2 cube, okay, 2 per n. N is this 3 outputs. So now let us give the connections according to the diagram, okay, and then we will see after giving the circuit connection we will fill this table. Okay, after filling this table, uh, yeah, you have to explain the truth table. Just see this now. So let me give the connections, and you know that for encoder we use OR gates. So let's go back to this, and I'll select a new project, make it big. So this octal to binary encoder. For this you will have how many inputs? Let's take switches 0 to this is D0, D1, D2, D3, D4, D5, D6, D7. Okay, so let me give the names to them. Okay, and also we have OR gates, only 3 OR gates, and the LEDs. Sorry, LEDs. Okay, yeah. Now let's give connections. Before I give connection, let me give the names to all of them with the help of text. Okay, so output, what is the output here? Showing this XYZ. Okay, so the output is X, Y, and here D0 is D1, and this is D2, and this is D3, and this is D4, this is D5, this is D6, this is D7. Okay, so now I give connections. Okay, another important thing is these inputs, this should be 4-bit input. Okay, so I just go to the properties of OR gate, make it 4 inputs. Yeah, to make it 4 input, I should not have any connections first, because I have to change, because as you have seen that these are 4 inputs, right? So I give 4 inputs. Okay, go to properties and select for 4 inputs, go to properties and select for 4 inputs. Okay, so now I give the connections for X. Okay, so it is giving from here to here, and then from the 5 to second input, and the 6 to these inputs, and the 7 to, okay. Now you see the next I get this coming from D2, okay, D3, D4, D6 and D7. Okay, so I just give, this is going, Y is going from D2, D3, then D6 and D7. Okay, similarly Z is going from D1 and D3 and D5 and D7. Okay, and just connect them. So once you have connected, now let's check the output. Okay, so when D1 is 1, so it is those binary sequences, uh, because D0 is data link 0, binary sequence is 0. So here I just make a note that when D0 is 1 here, so all are zeros. So let's write all of them are zeros. Then I make D1 as 1. Okay, so I make D1 as 1. So it is giving me Z as 1. So this is 1. Then I make D2 as 1. Okay, when I make D2 as 1, so it is giving me D2 is 1 0. Okay, then I make D3 as 1. So I get the last two inputs as 0 1. Then I make D4 as 1. I give 1 0 0. I make D5 as 1 now. Okay, so I get 1 0 1. You see it is giving the binary equivalent. And when D6 is 1, so I get 1 1 0. And when I make this D7 as 1, all are 1s. It is giving me all are 1s. So you observe that what value of the data line is D3 is 1, then binary equivalent 3 is given. So only you are having 2 per n number of inputs, but only one line is connected to the output. Okay. So explain this table in your own words. The next, which is there in the next slide here. Okay. So explain the truth table in here to explain the truth table. So you have to explain the truth table in your own words. So once you have understood this, now let us see and do the last part. Yeah, this is yeah. So now here, let's see this part. Draw the circuit for 2 to 4 line decoder. What do you mean by 2 to 4 line decoder? Sorry, 2 to 4 line encoder. It means you are having two inputs. So 1 minute. This is 4 to 2 line decoder, right? 4 to 2 line encoder. So you are having inputs, and here you are having output. So the input is 4. 4 means 2 square. Okay. So here output is n is 2 here, 2 per n. So you will be having 4 inputs and uh, 2 outputs. So in this case, it's like this. So you will have all these 4 inputs and 2 outputs. Right. So inputs are we have D0, D1, D2, D3. Okay. Like how do you have in the previous example? So, and you'll get an output of X and Y. So, if this is 1, remaining all are zeros. Okay. So, D0 means binary equivalence is 0. If D1 is 1 and all are 0, so you will get 0, 1. Okay. And if D2 is 1, so you get 1, 0 as an output. And if data line 3 is enabled, then binary equivalent is 1, 1. Okay. So I just put it here. We can get this table here for inputs and outputs. So here you can write the Boolean expression very easily. Okay. So for x, the Boolean expression is okay. Here you see one are only at these 2 locations. This 1 means D2 is 1 here, plus, and this 1 means D3 is 1 here. D2 plus D3, you will get the expression for x. Okay. And then for y, you see this is 1, means in this row the 1 is D1 plus, and this is 1, here D3 is 1. So you can draw the circuit very easily. You will have how many inputs? You will have 4 inputs. Okay, D0, D1, D2, and D3, and you will have 2 inputs only. So this is an OR gate for X and another OR gate for Y. So you will have X is from D2 and D3, and Y is D1, D1 and D3. So this is the circuit. You can draw the circuit and check that you'll get the same output. And in the similar way, here also, like here also you can write the Boolean expressions for x, y, and z. So here you see here for x, x is equal to, now you see x is 1 at D4, D5, D6, and D7. So x is D4 plus D5 plus D6 plus D7. And the expression for y is, you can see y is 1 here. So D3, D2, D3, D6, D7. So D2, D3, D6 plus D7. Similarly, for Z also, you have D1, D3, D1, D3, D5, D7. Okay. So D1, D3, D5 plus D7. Okay. So this is how you are supposed to complete your lab report. And here, make sure that you write the types also. So we'll stop here. If you have any questions, you can ask.